In this video, we are going to be utilising bearings in conjunction with Pythagoras to solve this particular question, which I've labelled as example 7. It's a similar question to example 5 and example 6, where likewise we're using bearings in conjunction with Pythagoras to solve. Now this one's a little bit more challenging, but once again it's still using the same tools that we have used in previous examples. The question reads: a hiker travels 4.7 kilometers from a starting position at a bearing of 315 degrees true. The hiker then changes direction and walks another 5.9 kilometers on a bearing of 225 degrees true. How far is the hiker from their starting point? Do not just assume that the triangle is a right-angled triangle. That's what this symbol is. It is suggesting a right angle. Now we can't just assume it's a right angle as this suggests. We have to show that there is a right angled triangle. Now the most important part of the problem regarding generally Pythagoras and trigonometry, and bearings for that matter, is creating an illustration which best represents the information in the question. Now I've started at some point which I've labelled as the start. And what I've done, and you can see it lightly here by this circle or this angle here, is at that starting point from true north, which I've drawn in with a dotted line, I've measured, not with a protractor, but approximately 315 degrees in a clockwise direction. That's a clockwise direction from true north. And I've drawn that bearing on that particular leg, as well as the distance that the hiker walked for that particular leg. I then put another point to represent the change of bearing, and once again drew in my true north arrow, and you'll note that I've also extended the true north arrow. Now you don't need to do that, but it might help you recognise some things in this image that you may not recognise as if it wasn't there. I then noted that the change of bearing was from 315 to 225, so at this point from true north, and you'll note the old faded light line here representing our bearing of 225 degrees from true north and a distance of 5.9 kilometers to some other point. That's all the information we're given. Now you'll note that there are values throughout this illustration that you're not given. For instance, you're not actually given this value here, nor are you given this, this, or this. These you can rationally figure out using basic geometry. So I've rubbed this one out because this is the important one that you need to show with regards to determining that this triangle is a right angled triangle, and not just assuming that it's a right angled triangle. Now if this is 315 degrees, this first bearing from true north, and a full revolution or full rotation of a circle is 360 degrees, then this angle must be the difference, or equal to 360 subtract 315 degrees, which will give me this remaining angle, which is 45. That's how I got that one. I also got this angle here by recognising that true north in every instance is going to be running parallel, okay, because they are true north. So these are parallel, and one of a geometric rule that I can use is recognising that when I have parallel lines, these angles within or contained within those two parallel lines, I like to call them the U rule because it sort of forms like a U, they must add to 180. Therefore this angle here must be equal to 180 subtract 45, which I've just shown you how to find, which is equal to 135 degrees. Now to get this right angle, I need to show the value for this angle. The reason being is we have at this point three angles at a point. We have the angle contained within the triangle, this angle 135, and this unknown angle here. So if we know this, we can calculate this. Now, assuming that this, or let's not assume that this is a right angle. If we know that the bearing for the second leg being this shape, the lightly drawn in curved angle here, is equivalent to 225 degrees true, and there's 360 degrees in a circle, then this angle must be equal to 360 take 225, which is equal to 135. And once I see that as a teacher, I can recognise that they've shown me that and they've calculated that in order to rationally show that this is 90, because 135 and 135 and 90 degrees equals 360 degrees, which is the sum of those three angles at that point. Alternatively, you could say this angle, if it's unknown, is equivalent to 360 degrees, subtract 135 degrees, subtract another 135 degrees. Once again, two parallel lines. Both angles must add to 180, therefore this angle is 180, subtract the 135, which gives me the 45. Now that we're there, you'll note that we've got two known sides, a right angle, therefore we can use Pythagoras to solve. So it's just a simple Pythagoras solution now, which is a matter of writing Pythagoras' theorem, which is c squared equals a squared plus b squared, substituting those values we know into the formula. We have written this value x with regards to the unknown in the question. How far is the hiker from their starting point? Okay, so this is the distance from the starting point, the end point here in our start, represented by x, which is our c value being the hypotenuse in Pythagoras. Okay, so if you're still not entirely sure with regards to what this side is regarding Pythagoras' theorem, just go back and label your triangle. The hypotenuse in Pythagoras is c, leaving a and b, which we don't realistically need to worry too much about regarding what we call what. I like to call the smaller one a and the bigger one b. So substituting in for a and substituting in for b into Pythagoras' theorem, we get this, and then expanding what we have on the right hand side, we get these two values, which we then need to add together, giving us a value of 56.9, which we then need to square root in order to get x just by itself, because we need to remember that this is still all x squared. And write it in if it makes you feel a little bit better, or you feel that you'll get the answer correct more often than not, should you not write them in there. So write them in if it helps. And then we state, to solve just for x, we need to take the square root of the right hand side, which is equivalent to 7.54 kilometers, suggesting that the hiker is 7.54 kilometers from their starting point, x.